You can write a function using function notation in which you use fx instead of y. You read this as f of x. You can think of domain value as the input, so x is the input, and the resulting range value as the output. So what we normally called y is the output. A function rule is an equation that describes a function. So previous lesson we learned that y is equal to mx plus b. And this is an equation for a linear function. And what this is saying is that in some classes and in some textbooks, instead of the y, you might see it written as this function where the input is x is going to be equal to mx plus b. So f of x is the same thing as y. For my particular class, I really don't care too much if you use f of x or y. I prefer the y, but some teachers do care when you see f of x. They want you to write it with the f of x instead of the y. I'm going to use a function rule to help me write equations or write a rule to fit a certain situation. So here I have write a function rule to express the number of feet, n of d, as a function of the number of yards, d. So here my input is going to be the number of yards. And I'm going to use the variable d to represent that. And so I know that there are 3 feet in 1 yard. So my function would be the number of feet, input the number of yards, is going to equal 3 times the number of yards. So here's my function rule. N of d is equal to 3d. And what does this mean? Well, let's look at part B, where what would I get for 4 yards? So I would input the 4. So it would be 3 times 4, which is equal to 12. Notice how I did the input there, and then the input there to get my output of 12. So it would be 12 feet. As I was saying earlier, function rule and equation are the same thing. Instead of using y, I use f of x, or in the previous example, I used n of d. And so let's say I want to write the rule for this line right here, or I want to write the equation. So I want to put the equation in slope-intercept form, which means I want it to come out to be y is equal to mx plus b. Well, the y and the x are going to be your variables for the ordered pairs. So that's still your x, y values. Input, output. So really what I need to find is the m and the b. And remember, m is slope, and b is equal to y-intercept. And remember, with y-intercept, that means the value of x is 0. It's where it crosses the y-axis. And if I run down the y-axis, I see that this line crosses right there at -3, or -3. So b is equal to -3. That is my y-intercept. My slope, I can use rise over run. Rise over run to find my slope. So here I have my y-intercept of -3. I'm going to find my slope. So I'm going to go from, pick 2 points. So I'm going to go up 1, right there, So my rise is 1, and I'm going to go to the right, 1, 2. So my run is 2. So there's my slope. And I can tell earlier that this slant here, that slant there is a positive slant, so I know my slope is positive. So now I have the information that I need. Y is equal to m, which is 1/2 x, plus, and my slope is -3, so plus -3. And of course you could rewrite this to say y is equal to 1/2 x minus 3. So this would be my equation or my function rule for this line here. So we just discussed how to find the rule or the equation when you were given the line on a graph. You would find the slope and the y-intercept. And if you're just given a list of ordered pairs, all right, here I have a table with the x value, which is the input, and the y value, the output. So these would be ordered pairs for the graph. So it would be like -2, -5, and 0, 1, 2, 7, 4, 13. Well, let's say we didn't have room to graph it, but I wanted you to write the rule for the equation that contains these points here. You could still do that simply by finding the slope and the y-intercept. So the slope, remember, is the same thing as delta y over delta x. So let's find the slope. Remember delta y. So I just look for the change. -1 to 6. Right? That's a change of 6. Same thing, -2 to 0. That is a change of 2. So if I simplify that, I would get 3. So my slope is 3. Now what about the y-intercept? B. Remember, x is always 0 at the y-intercept. So if I go down this list, I see right here x is 0, and when x is 0, that means y is 1. And so my y-intercept would be 1, because the x is 0, the y is 1. That is a point on the y-axis. So now I have my slope and I have my y-intercept, so I can write this equation or rule using slope-intercept form. So y is equal to mx plus b, so it would be y is equal to 3x plus 1. That would be my equation or my rule for the line that contains these points right here in the table. Let's look at one more. Let's say I have a table and it doesn't give me the y-intercept in the table. So I have the table here. All right, I'm going to draw it out. X, y. So when x is -1, y is -2. When it's 1, 2, 2, 4. So I can still find the slope, right? I want to try to find the equation. So I'm looking for the slope and the y-intercept. So I'm looking for the slope and the y-intercept. So how would I find that? Well, let's find the slope first, m. So I know that 2 to 4 is 2. That's my delta y. So my delta y is 2. My delta x, 1 to 2, is 1. Right? So 2 over 1, that simplifies to 2. But what about the y-intercept? I look down the list here, and I do not see x is equal to 0. Now I could look for a pattern and maybe come up with the value, but you could also solve for it mathematically. So I know that the slope is 2, so I can put that in there. Y is equal to 2x plus b. Well, we only know how to solve for one variable, but we're looking for the b. So do I know an xy value? Well, yes, you do. All you have to do is just go back up and pick a ordered pair from the table. Because when x is 1, y is 2. So I can substitute those values into the equation that I've just started. So y is 2, x is 1. So there's my slope x is 1 plus b. Now I just have one variable, and I can solve for that. So 2 is equal to 2 plus b. Let's solve for b, so I subtract 2 both sides. So b is equal to 0. And I can use that now to write my equation. Now that I know that the y-intercept is 0, I've got the slope of 2. My equation or rule for this would be y is equal to 2x plus 0. And since I know anything added to 0 is itself, it would just be y is equal to 2x. So remember, if you're not given the y-intercept in your table, you can solve for it by substituting in an xy value from the table to solve for b.